right, the first question is, what have you learned from your college career that you think will be most useful in your future career?
Okay. All right, my name's Josh, you all know that. The question was, what have I learned in my college career that I think will be most useful in my future career? So, like right now, I'm not really entirely sure where I'm gonna end up, but this question, I feel like it kind of depends on the craft you have, like where you are gonna be in the future. I would say like in general, the most important thing that I've learned would probably be like time management. Because obviously like for this, it's studying and like doing stuff outside of school to make sure I do decent in class. In like a job, like in my internship, you had to know how to manage your time so you can complete multiple tasks because you're not just going to be doing one single thing your entire time. But you can also say that like with classes, I've done a lot of work with like heat transfer stuff, instrumentation stuff, like thermo stuff. Like all of the classes are very useful skills to have, but it all comes down to like focusing, depending on your craft. Like you might be doing something where you're doing more like heat transfer work, like you're doing like piping and stuff like that, like piping insulation. You know, you're gonna be doing more like heat transfer stuff. So that's more like specific to what you're doing. But I would say like overall the most important thing is definitely probably time management, because like I was a project engineer, so like, you know, I had multiple projects going on at once, so you gotta be able to stay on topic with one and do other things and get stuff done, and a lot of time is going to be spent outside of like normal hours. I mean, like I said, it all depends on what you do. I mean, you might not be working overtime while you're in. Yeah, that's about it.
What are your thoughts on nuclear energy as a power source? Is it viable to use? Is it safe? Are there public misconceptions that prevent it from being used?
Yeah, so hi, I'm the other Josh in class. Yeah, so basically thoughts on nuclear energy as a power source. Is it safe, sustainable? What I've seen, I think nuclear energy is, of what I've heard, it's like the cleanest. Now obviously like that's a little bit like misconstrued of what people like think about. It's like clean as in the energy, it actually produces the less like CO2 and carbon emissions and messes with the ecosystem the least. Obviously it has the, you know, green sludge at the end, but you know, although that is bad, we're really good at containing it, and every once in a while there might be like a nuclear disaster, but that's like very few and far in between. Like there are other clean sources of energy, like wind power is a big one. I guess hydroelectrical power, but those also have like drawbacks. Like wind power, it's apparently like it kills like a lot of birds, like so many that they need to be exempt from killing a lot of like really endangered birds, or else they'd be like under. Apparently, they would basically have to shut down. Another thing is for hydroelectric. I think for most places, they basically have max capacity for hydroelectric because there's only so many waterfalls, so many dams you can build, as well as like, have you ever seen the trout tubes? It's pretty funny. So it's like a big old tube from the bottom to the top, and then you send like trouts and salmon up because they only breed at the place they were born in, and so it doesn't mess up the population. They have a big old tube that just sucks them up. So. But honestly, I think nuclear energy's fine. I think, you know, Godzilla just made it have a bad rep, but yeah.
How has your capstone project progressed? What are some problems that you've run into and what has worked well? How have you addressed any challenges that you faced?
All right, so Devin, I think our capstone project is going pretty well. Our project is to design a mechanical clock or watch that has no like electrical input or anything of the sort. It's solely, you know, rotations of a, you know, of a crown or whatever. Y'all know what a mechanical watch is. One of the hardest things we've had so far was in the beginning. Our scope was so wide. We could have done anywhere from like a 40 millimeter watch to a grandfather style clock. So kind of refining that down was was very difficult and was like a big roadblock for us. Because obviously the engineering that goes into making something this small versus something this big, completely different things. They've got completely different functions. They got completely different constraints. They've got just everything. So that was very difficult and was like a good, like really hard roadblock for us to overcome. But luckily we were able to get it kind of honed in where it needed to be. And now we're working on, trying to get our gear train figured out on top of the never-ending deadlines of reports and classes and all of this such. And also sleeping, that's also an important thing that gets sacrificed. But yeah, so gear train, we're trying to do a bunch of research, trying to balance, reinvent the wheel figuratively and literally, and not reinventing the wheel and just doing something more practical. But still work in progress. Went and checked out a book from the library for the first time to help out, but still haven't had time to read the book yet. We'll see if it was worth the effort. But that's where my capstone project is now, and from the roadblocks.
Why is it important to follow safety procedures in a lab setting or in industry? What could potentially happen if they are not followed?
Hey everybody, I'm Adam, as you guys know, and so our question was regarding safety procedures in the lab or in industry, which is something I'm very familiar with since I work in safety for a company. So working in safety, you can see what happens very explicitly when safety procedures aren't followed. It's not necessarily always that someone is injured, but your process might be impacted if something is not followed, if a guideline isn't followed correctly. More often than not, you're going to have a slowdown, which is usually very aggravating to have that impact to schedule or that impact to cost, which is the big cost of quality discussion that a lot of companies have to do. On our labs, it's a much smaller scope. So if you don't follow a safety procedure, you might get something in your eye, you might have skin irritation, you might break a piece of equipment. But when you're talking about an industrial setting, depending on the sensitivity of the process or item you're working with, you could really slow down production and cost the company thousands, tens of thousands, millions of dollars. You could cost them a month. So the company I work at, they do large-scale aerospace production. And whenever a part that is considered a critical item is slowed down by a day, oftentimes because people don't follow procedures and something might be installed incorrectly, I was told every day it's about $1 million in cost. So if something's 6 days late, you're talking about a very large impact to the cost. There's also things like staff. So if you lose a staff member because they're out on an injury, or they need to be retrained because they didn't follow a procedure correctly, that can really impact your schedule as well. I know like industrial engineering do a lot of ergonomics work to make sure that any process that you're doing is safe and that you don't slow down or have excessive issues with that. So really just being safe ensures that you're able to do things the way that you set out to do them. You can have a set of instructions, but you need to follow them safely in order to do everything according to your cost and deadline. So that's the importance of that. Thank you.
Obligatory AI question. I had to put it in there. How can automation and artificial intelligence be integrated into manufacturing processes to optimize production efficiency without compromising quality?
Hey, I'm Patrick. Question is about AI and automation, manufacturing, and how can it be integrated? There's like, how can it not be integrated is what you can really ask. It's just every little step. I mean, we've seen automation like from a long time ago, starting just even in like regular factories in the assembly line. Everyone started freaking out there, like thinking their jobs are all going to be gone, and a lot of jobs have gone. But in even manufacturing, like if you can really break it down to even, you can look at like fast food places, like there's some McDonald's I think where they have, you just order at like a little kiosk and your entire order will just be made by robots, not even a person touching it. Just like, and it'll just come out in a tube, just like completely automated, no human interaction there basically. Or maybe they have someone like, just check the quality real quickly. And even Chipotle I've seen is trying to do that too, where they're gonna have just a robot that just makes your online orders completely from start to finish. And people are gonna be up in arms about that too, with jobs being lost. But I mean, maybe it's a good thing. I don't know if any of y'all have gone. They're always like really skimpy about their portions. Maybe the robots will do a better job at that. And in a more just straight manufacturing sense, it can just do a lot of the simpler tasks that have people involved in them, and maybe open up people to do more important tasks, or maybe it's just gonna put a lot of people out of jobs just simply like that. We'll just have to wait and see. That's what I got.
What do you think the future of cars will be, and transportation in general? Will the internal combustion engine be completely replaced by electrics and hybrids? Will there still be a place for it somewhere? Or do you think that we'll move away from cars altogether?
Hi, I'm Michael. So, questions on the board. A lot of words, I'm not going to repeat it. But I guess I'll be working in the oil and gas field, so I can't say that oil and gas is going to go away. But with that said, I don't know anything about the gasoline or any of that, so I would go with electric cars are the future. So you can, because they go 0 to 60 real quick. You're gonna fly much faster. You can maybe, hopefully, beat a Lamborghini in a race with the Tesla. A dream right there. You can talk trash on that. But then, other things electric cars have, lithium. I love lithium. Coolest element periodic table there is. So, who wouldn't want lithium in their cars? And then, all this combustion stuff, too technical based, too much like stuff we don't know about in the real world. So, electric, everyone understands electric stuff. So, electric cars are easily the future because it's easy to understand. But something that's not on there is, I saw something like on like Instagram or something, that there used to be like water car, but the guy like died and it didn't pan out. But maybe that's the future. That's it.
You know anything about like cycles?
What lab have you done that you found most interesting? What did you learn in the lab that you couldn't learn in class? And how did you apply your theoretical knowledge to the hands-on activities?
Okay. What's up, everybody? My name's Christian. And the question was, which lab would I say is my favorite? And I would say that is probably manufacturing lab, because it's the first time in the mechanical engineering flowchart that you kind of actually like get to do interesting hands-on work other than just like tedious little labs here and there, like breaking like 5-centimeter pieces of steel apart and stuff like that. Like you get to get a bandsaw, you get to cut steel and weld it or cut it and watch the CNC machine do it. So I think that was my favorite because it was the most hands-on, but also a lot of that stuff was at least taught to me by Wahab, who is kind of boring, I think some people would say. So it was a lot more helpful to be able to like see how the processes happen in person and like noticing all the minute little things and like seeing that like when you're welding, like the speed actually does matter and they're not just kicking you in the balls about it or something, I don't know. But yeah, and I think a lot of the processes seen in that class are like a lot more of the things that we would encounter in the field. Like we're not gonna do a Sharpie hardness test and break the little piece of steel, but you might have to do some like CNC machining or like some welding for whatever job you go into. So I feel like those are the most beneficial types of labs and classes. So that's it.
As you approach the latter part of your college journey, what areas within the mechanical engineering curriculum do you feel most passionate about pursuing in your future career? So what really drew your interest?
Okay. Hi, my name is Al, and the question is about what am I passionate about pursuing in my future career. And I don't know, currently I'm not pursuing anything, but I'm interested in three mechanical engineering areas. First one is additive manufacturing. I think additive manufacturing is really cool. I'm taking manufacturing class that's a tech elective, and there was this one lab that if you want to print a real part and you can 3D scan it, so basically if you want to 3D print a hat, you can scan it and flip it, and you gotta get all the parts inside of the hat too. And I think that's pretty cool. You can apply it to anything basically. And another mechanical engineering that I'm most interested in is nuclear power basically. So most specifically fusion nuclear power. I think it's the most cleanest nuclear power. Josh was talking about the fission part where you had a lot of waste. I think that's pretty cool too. And the last mechanical engineering areas I'm interested in is aerospace. I've taken Dr. Menon for flight mechanics, and I think it's pretty cool. But, yeah. Super.
In class. I wasn't here. I know I do too.
What classes or concepts or anything broad like that from your coursework have you found the most challenging, and what did you do to overcome those challenges?
So my name's Claire. I'm a sixth year, so I feel like it's like what hasn't been challenging. I guess if I were to start anywhere, it would be with thermo the first time. The biggest challenge was, it was like the first, it's like the first hump. Like they're trying to weed you out. There's a lot of work that you have to do. You have to put in the work to be successful, and I just didn't know that, didn't fully grasp that. So what did I do to overcome that? I took it again, but then COVID happened, and then I didn't really put in the work then either. So I overcame that by taking it again. And third time was the charm. So I learned through that process that I had to put in the work. Like I had to study consistently. You have to do problems every day, and I feel like that applies to pretty much all of our classes. You have to literally work on them every single day, especially whenever it's problem based. You're getting the experience, but also someone said earlier, like time management is one of the hardest things, and I'm still trying to fully grasp that. 6 years though is my cutoff. Can't go to a 7th, so I'm trying to figure all of that out the best I can. I think another challenge though is sometimes like there's very different personalities in our classes, so like just kind of learning to work with everybody is huge, because if you can work with every different type of personality, then you can succeed. And that's all I got.
Considering.
In the context of additive manufacturing or 3D printing, what are the potential advancements and limitations? How might this technology reshape traditional manufacturing processes?
Hey, so my name's Noah behind the mask, and the question was pretty much just what advancements and limitations 3D printing is going to have. And I think the largest advancement for sure is just going to be the addition of new materials, because like that's been kind of going on for the past few years, but we're just starting to fully like get more understanding of steel welding additive manufacturing, and like that's something that Dr. Go is doing just right now. So eventually we'll probably be able to get that a lot more sorted out, potentially to the point where it's like almost fully understood, kind of like more traditional plastics are. And aside from that, I think one of the key limitations for it is just the time it takes, because like you can't really speed up moving a gantry to a certain point, and if you are doing specifically like an extruded 3D printing process, it's going to be like, it's always going to be limited based off of the total volume of the part, because you're printing it pathwise and not like just the whole layer at a single time. And honestly, there's certain things where that time is never going to be better. Like if you're trying to make a steel tube, 3D printing it is going to be so much more annoying than just rolling a tube, like rolling sheet metal and welding a single seam. And it's going to have so much more room for imperfections in that tube that it's just not worth it. And like, might as well just not even try to do that, because it's just worse. I think that's the main limitation and benefit, in my opinion.